Hey 7th graders, this is lesson 4, session 2 in your book, which starts on page 65. This week we're still working on proportional relationships, and today we are interpreting graphs of proportional relationships. And you know it's a proportional relationship on the graph if it does two things. If it goes in a straight line, and that line goes through the origin, 0, 0. It is a proportional relationship. So we can see that right off the bat in our try here. We have a proportional relationship because all those dots fall on the line, and that line goes through 0, 0, the origin. So what I want you to do here, I'll read the problem out loud, and then I really need you to pause and try to figure this out on your own before we peek at the next page, because the next page is going to tell you how to do it. But you can probably figure this out on your own if you give yourself a couple minutes. So I'll read the problem, and then you're going to pause to figure it out on your own. So this problem says, Ignacio is making chiles en nogada to celebrate Mexican Independence Day with his family, and hopefully he's inviting me because that sounds delicious. Ignacio needs to buy poblano peppers. The local market sells poblano peppers by the pound. How much will 1 pound of peppers cost? How much will 3.5 pounds of peppers cost? Go ahead and pause and see if you can figure out the answer to their question there. Okay, so hopefully you've at least tried to figure it out. Now there's two basic ways to figure it out, and I'm going to show you them on the next page. So the next page, at first it has this model. There's our first model here. It says you can write an equation that represents the proportional relationship. So what they've done is they went and they found on here one of these points. And you only have to pick one because they're proportional. They're all equivalent to each other. So only 1 point. You only need to worry about 1 point. And that says that 3 pounds of poblano peppers, I should say, is going to cost $9. So it says the ordered pair 3, 9, 3, 9, 3, 9, 3, 9 shows that it costs $9 to buy 3 pounds of peppers. So to find how much it costs to buy 1 pound, we're going to just divide $9 by 3 pounds. That's $3 a pound. Each pound of peppers costs $3. And that is called the constant of proportionality. So that just means everything on here is increasing by 3 each time. And it's not, notice it's not 3 spaces because these on the side, on the Y here, it's skip counting by 3. So it's cheating on us a little bit, but that's okay. So the constant of proportionality here is 3. And we can write this as an equation, so keep this kind of equation in mind because you're going to be doing this kind of equation a lot this year, and you're going to look at this kind of equation most of 8th grade, it feels like. So y equals 3 times x. So remember, the y represents the cost, and the x represents the pounds of peppers. So all we're doing here is we are taking the pounds of peppers. Every time we decide how many pounds of peppers we want, we multiply by 3, and that'll give us the cost. So if we want to do 3.5, we would just do y equals 3, because that's the constant proportionality, times how many pounds? 3.5. We'll do that a little bit on the next page. The other way you can interpret the graph is, well, we already drew a line through all the points, and then you just find the data that you're looking for. So if the data you're looking for is price per pound, you find 1 pound, and you find where it hits on the line, and then you go over to the cost, which is $3. Or you go over here to 3.5 pounds, the other cost that we wanted, and then you go up to where it hits on the line, and that is right in the middle of 9 and 12. And the number that falls exactly in the middle of 9 and 12 is 10.5. So, and this is true for what happened up here as well. 3.5 times 3 is $10.50. There we go. So now let's analyze these a little bit more down here on the next page, which is 67. use the equation in the first, model it. Okay, so that equation was money is pounds of peppers times 3. That was the equation it gave us. The constant proportionality was 3 there. How can you use it to find the cost of 1 pound of peppers, of 3.5 pounds of peppers? So if the x here represents the pounds of peppers, then all we need to do is plug in the pounds of peppers, and that'll give us our y there. So how can we do we want to do it? No, we don't want to do it. Let's just explain it. I got my text tool so it's nice and tidy, and say you can substitute the pounds of peppers 1 or 3.5 for the x. Then y will be the cost for that many pounds. There you go. That's how we use constant or proportionality. That's why proportional relationships are, it's important to know the constant of proportionality, because all you really have to do is multiply that. But now let's look at the graph in the second, model it. What do 1 pound and 3.5 pounds of peppers cost on there, and how can you tell? Okay, text tool. They cost $3 and $10.50 respectively. And we know this because we can tell because the point on the line with the x coordinate, because remember x coordinate represents in this situation the pounds of peppers, and that has a y coordinate which represents our money. The x is the pounds, the y is the money, of 3. And the point on the line with the x coordinate of 3.5 has a y coordinate of 10.5. There you go. Alright, now let's talk about the origin a little bit. So remember, 0, 0 is called the origin. And it's asking us first, what does the point 0, 0 represent in this situation? Well, if x is our peppers and y is our dollars, it represents 0 pounds of peppers cost how many dollars? $0. There you go. But now the second part of the question, why is the point 0, 0 part of the graph of any proportional relationship? Remember, I said at the beginning that one of the important things for it to be a proportional relationship is that it must pass through 0, 0. Okay, so why is it part of any proportional relationship? How do we word that? Let's see. Since 0 times any, we'll put that in italics, any number is 0, multiplying the constant of proportionality by 0 will give you 0. Will always give you 0. So I'll write that example here with our example equation that we had used. Hey, don't change my text color. So our equation was y equals 3x. So if we buy 0 pounds of peppers, y equals 3 times 0 pounds of peppers. So y equals 0. Oops, I don't need a parentheses there. Y is nothing. Okay, so remember that proportional relationship on a graph must always go through the origin, 0, 0, because if you buy nothing of something, if you buy 0 pounds, you spend $0. What does the point 1, 3.5 tell you? So same situation here. This is pounds of peppers, this is dollars. It tells us that 1 pound of peppers is $3.50. They raised the price on us. Rude. Okay, number 5 here says which point gives the unit rate or constant of proportionality. So it's using these two terms interchangeably, because remember the unit rate is the per one, the miles per gallon, the dollars per pound. So that means per one, and that ends up being the same thing as the constant of proportionality. So they're kind of interchangeable terms there. So which point gives the unit rate in any graph of a proportional relationship? And that is going to be the point with a 1 in it, because unit rate means per one of something. That answer works for me. It's not the answer that's in the book, but I like it better. Number 6. How could you use the graph of a proportional relationship to find any ratio in the proportional relationship, and why does that work? Okay. I could pick any point on the line to find the ratio, because all of the ratios on the line will be equivalent. Because that's what proportional means. That's the definition of proportional. I hope you're writing, and when you write proportional, you write it in italics. Okay. And then the reflection question is for you. Which way did you like best? What out of all of these pages and questions, man, that looks delicious. I need to learn how to make that. That looks yummy. What out of all of these strategies, these questions, is there anything in here that made you better understand how you could have solved this? Or did you already do it perfectly the first time? But what helped you understand it better? Anything on here? Go ahead and pause and answer number 7, because it is important to reflect. So go ahead, pause. Okay, did you do it? Did you pause? I hope you did it. We're going to do 3 practice problems together now. And this is page 68. Then after these 3 practice problems, you're going to do your green pages on your own. Number 8. Alejandro babysits in the evenings. He makes a graph to show the money he earns. How much money does Alejandro earn for each hour of babysitting, and how do you know? Well, we find the hours babysitting, and it says for each hour, so we want to know the unit rate. We want to know his per hour cost. That's the unit rate. So we look at 1 hour, and we go to the line. And the y coordinate that matches that x coordinate is $15. $15. And how do we know? How can we word that so that we can put it down on paper? How do we know? Let's think. Let's keep it simple here. The line on the graph goes through 1, 15. That's how we know. Okay, number 9 here. Indira makes a graph to show how many pages of her graphic novel she can illustrate each day, because she's a very diligent and productive worker. I want to see her graphic novel. What is the constant of proportionality for the relationship between pages and days? And remember, constant of proportionality is interchangeable with unit rate, so that means per one. We want to know how many pages per day, per 1 day. And does it give us that? No, not really. I mean, it does. It's right here, but what is this? What is that right there? We can go, let's do an easier one up here. We've got 2, 1.5. Okay, well that's 2, 1.5. So all I'm going to do here is I'm going to do 1.5 divided by 2. Okay, 1.5 divided by 2. I'm going to change that mixed number to an improper fraction. I'm going to do 2 times 1 plus 1. 2 times 1 is 3, plus 1 is 4. No, 2 times 1 is 3. Why is it 2? 2 times 1 is 2, plus 1 is 3. I'm going crazy over here. Divided by 2. And if you recall from last year, because I know I taught you this, we're going to do keep, change, flip, because you already know how to turn a whole number into a fraction. You put a 1 under it. Okay, and that's going to give us 3 times 1 is 3, 2 times 2 is 4. So this right here is not a question mark. Get out of here, question mark. It is 3/4. 3/4 of a page per day. Write an equation to show the relationship between pages and days. Okay, well, if our constant of proportionality is 3/4, and x represents our days, and then we just stick y over there. However many days times 3/4 will give us how many pages she was able to do. So that's the format for all of these proportional relationships, is y goes on this side, x goes on this side, the constant of proportionality, or the unit rate, goes with the y. That's the format. Okay, last one here. Alema's little sisters want box braids. They complain that Alema braids too slowly. That would take forever if you do it too slowly. So she makes a graph to show them how fast she is. Well, that'll show them. Let's see. What does 0, 0 mean? Well, we've got heads of hair and hours. How many hours it takes her to do a head of hair. So this is 0 heads. Takes 0 hours. What does the 0.00 mean? 0 heads takes 0 hours. Now, what would 1.5 to 5.25 mean? Well, this is heads and this is hours, so I'm going to change it to fractions just to mess with you. 1.5 heads will take her 5.25 hours. There you go. Okay. That's it. Good luck.